Hi, this instructional video is on the distributive property. We are going to use the distributive property to generate equivalent expressions. So we are going to work with multiplication over addition, and the product of a factor and a sum is equivalent to the sum of the products of the factor and the add-ins. Okay, so those add-ins are things you add together. I want you to think about, while we're doing this, the distributive language is distribute, expand, factor, remove grouping, and combine like terms. So first, when you see this graphic organizer, you're going to see this side is called a sum. And it's called a sum because it uses the addition symbol. This side is considered a product because we are multiplying. Okay? Now, equivalent expressions, we know that 14 equals 2 times 3 plus 4 in the brackets, and 2 times 3 plus 4 in the brackets equals 14. So they are equivalent expressions, okay? And here, when you see this, A times B, A times C, you're looking at this, A times B, A times C. So A times B gives you here A times C. So if it help you understand doing it in a distribution like this, you can always make a table, okay? Now we're going to do some practice, and I want you to take a look at the problems, and I'm going to pause for just a minute. All right, another thing is, I know you've taken a look at it. Thank you. And if you want colored pencils to help you when you take notes, I'm going to pause again, and you can get, I would get like 2 or 3 different colors. Okay, so now we're going to make equivalent expressions. So the expand distribute is what we're used to, okay? So 5 times 12x and 5 times 8. I'm used to doing it making arrows. It helps me know what to do. So 5 times 12 is 60x. 5 times 8 is 40. Okay? So that will give you an equal expression. Okay? And I'm just going to make these arrows so that you know that they equal each other. The color really doesn't mean anything in this particular case. Now the next one, x times 3, x times 4 plus 8. Now this is not in parentheses. So the first thing we do is remember your order of operations because they're like terms. You're going to change that to 7 plus 8. Then we're going to multiply 7, 8 plus 7x, plus 8. So now these, I'm just going to be using different colors. This and this are equivalent expressions. Okay? Now the next one, whenever you see just a minus sign, let me bring this up so you can see it. Okay, there we go. Thanks for your patience. This will be a 1. You always put a 1 there. So it's 1 times 2x and 1 times plus 1. So we're going to do negative 1 times 2x because we can't combine these because they're not like terms. So negative 1 times 2x is negative 2x, and negative 1 times positive 1 is negative 1. Okay? So again, these, I'm going to pick a different color. These are equivalent expressions. They mean the same, they equal the same thing. That's what equivalent means. Okay, now here, we're going to take and we're going to break this down. And usually we try and find a common factor when we want to break it down, okay? But here we know that x is the common term, right? And then we're going to do 5 plus 12. So then we know that we combine in the parentheses. So it's x times 17, or you can write it 17x. Okay? So again, these are equivalent terms. Now, this one, the common factor is 2. So if I divide negative 6 by 2, I'm going to have, in parentheses, negative 3 minus 5. Okay? And then again, these are like terms. So negative 3 plus negative 5 is negative 8. So 2 times negative 8 is negative 16, which is an equivalent expression. Okay? Now the next one, the greatest common factor here that we can use is 3. So if we multiply 3 times negative x plus 3y, okay? So that way we know that if we multiply, this is considered a 1 in here. So 3 times negative 1 is 3x. 3 times 3 is 9. So it's 3y. So again, we have another set of equivalent fractions. Okay? Now, give you a minute to take that down, and then I'm going to pause, and I want you to either, are you going to distribute this, or you're going to factor it? Okay, so think about what you're going to do for each, and we'll go over that. Okay? I'm going to pause it for just a couple minutes. And remember, if color coding helps, go ahead and use it. Okay, so we're back again. So now, to me, I'm going to use this one as the distributive. And I'm going to go 10n plus, so 10 times n, and 10 times 17 is 170. Now this one, I'm going to break it down. And to me, 7 go into 14, so I'm going to do 7. And remember, there's a 1 in front of the b if it's by itself, plus 2. Okay? So if you do it out, it's 7b plus 14. So you see how they're equivalent. Okay? Same here. Now when we do 36 plus 24, I know that each one of these can be divided by 12. So 36 divided by 12 is 3. And 24 divided by 12 is 2. But we have to add the y. Okay? So if we were to go back, it would be 12 times 3 is 36. 12 times 2 is 24. And we keep the y. So these are equivalent expressions. Okay? Now this one's like the distributive property. 9 times 7, 9 times 2b. I'm sorry, I'm trying to keep my hand out of the way. 9 times 7 is 63, plus 9 times 2 is 18b. So again, these are equivalent expressions. I've got to find my red pencil. Okay? And now the last one is also distributive. So 12 times 5 is 60, and we're going to remember the a, plus 12 times 7, 12 times 7 is 84. Okay? I just want to make sure I'm doing that right. 7 times 2 is 14, carry the 184. Okay, perfect. All right, so now these are equivalent fractions. Okay, check your work. If you have any questions, please talk to the teacher and we'll try and clarify any misunderstandings. Okay, great job. Thanks for listening and have a great day.